Okay, so today we're going through more shapes, more properties. Before we get to the more shapes and more properties, what shapes have we covered so far? Type in the chat, what ones have we covered so far? Yeah, we got parallelograms, there's one, squares, rhombi, rectangles. Awesome. So far, everything that we've covered has been like a special version of a parallelogram or just a regular parallelogram, right? But today, we're still and they've all been quadrilaterals so far. Today, though, we're going to cover two more quadrilaterals that are not special parallelograms. So these ones are different than parallelograms and don't have the same properties as parallelograms. They have their own special set of properties. So today we're looking at trapezoids and kites. So go ahead and take out whatever you're using for notes, and let's get going. Make that bigger. Come on. Okay, there we go. Now we're not falling off the desk. All right, so today we're going to start with trapezoids. And this is 7.5. Trapezoids and kites. So if you've drawn kites in a drawing as a kid, it's the same kind of kite shape in general for your basic shape of it. But we'll start with trapezoids. Okay, so some special properties of trapezoids. We have two things that are important here. First thing, they have one pair of parallel sides and one pair of non-parallel sides. Okay. They have one pair of parallel sides and one pair of non-parallel sides. The parallel sides are called the bases. Kind of like in the base angle theorem on an isosceles triangle, we named one side the base. Well, the parallel sides on a trapezoid are both called bases. A lot of times you'll see them referred to in formulas as B1 and B2 and stuff like that, but we'll get to that in a moment. So that's the first thing. Second thing is that consecutive angles off of the bases add to 180. So what we're looking at for a trapezoid is a picture something like that, where we have one set of sides that's parallel. Those are the bases. A lot of times you'll see it referred to as B1 and B2. And then the consecutive interior angles. So if we're thinking of these as parallel lines cut by a transversal, the consecutive interior angles are going to be like angle 1 and angle 2 here. And then angle 3 and angle 4 here. So measure of angle 1 plus measure of angle 2 is 180. And measure of angle 3 plus measure of angle 4 is 180. So those are kind of the special properties for a trapezoid? Okay. So for our first example, it's just going to involve finding missing angles. A lot of what we do with trapezoids is going to involve finding missing angles, although occasionally it will involve sides, and we'll get to that in a moment. Okay. So we want to find those missing angles. And the easiest way to do it is to just know that since it's a trapezoid, consecutive angles add to 180. So that means that these two angles will add to 180, and also that these two angles will add to 180. So we can just go 180 minus 35, which is going to give me 145, and that's going to be x. We can do the same thing here. 180 minus 92 is going to give me 88. And that's going to be y. Okay, so that's kind of a basic trapezoid problem that we're going to see. Any questions so far on trapezoids? Okay. Then there's one more special thing, or one more special type of trapezoid, and it's called an isosceles trapezoid. So just like isosceles triangle, we have an isosceles trapezoid, and it has a lot of similarities to an isosceles triangle, except that it's a trapezoid instead. So here we go. Isosceles, S-C-E-L-E-S, trapezoid. Okay. So an isosceles trapezoid has the properties of trapezoids, and so it has one pair of parallel sides, and then the other pair that's not parallel is congruent. And then secondly, it has the base angles are congruent. And then thirdly, still the consecutive angles add to 180. So it has all the regular trapezoid properties, plus the base angles are congruent, and the other pair of sides is congruent. So what we're looking at here, if we're drawing a picture, is that we have a pair of parallel sides, we have a pair of congruent sides, and then these are the base angles, and they are congruent, and these are also the other set of base angles that are congruent to each other. Okay. So for an example on this one, you could be given a picture like this. And know that this angle is 73 degrees, and be asked to find angles 1, 2, and 3. Okay. So in that case, we handle it pretty much the same way as we did the one up here, except we also know that angle 3 is the same as this other one over here that's 73 degrees. So we already know that measure of angle 3 is 73 degrees. And we know that angles 1 and 2 will be the same as each other. We just have to go 180 minus 73, which gives us 107, to know that the measures of angle 1 and angle 2 are both 107. Okay, so that's how we deal with angles on trapezoids. The last thing we need to know about trapezoids is something called the mid segment. So we've talked about mid segments with triangles before. Mid segments with trapezoids are going to be very similar. It's also it's a similar idea of what a mid segment is. It's just a little bit different in that the formula for finding the mid segment length is a little bit different. So here we go. Trapezoid mid segment. Okay, so the mid segment, just like on a triangle, it's a line connecting the middle of one side to the middle of the opposite side. Okay, so if we have a picture going here, these would be the bases, base 1 and base 2. This would be your mid segment. Okay, and the length of the mid segment is an average of the two bases. And to find an average, we just add them and divide by 2. So the formula we're interested in here is the length of the mid segment is equal to base 1 plus base 2 divided by 2. Okay, I'll give everyone a moment to finish writing there since I know I wrote a little bit fast. And then we're going to do some examples involving the mid segment. Okay. Anyone still need this? Anyone still writing? Okay, then moving along, examples. Involving the mid segment. Okay, so we're going to be told that this is the mid segment. If they don't tell you outright that it's a mid segment, but they have markings like this on here that show that this is the midpoint of this side and this is the midpoint of this side, then it's safe to assume that it's a mid segment. And we'll call this T, R, P, S, and then this will be M and N. And we are told that TR is 4, PS is 10, and we want to find MN. Okay, so this is one kind of problem we'll see with the mid segment, and the first thing that you want to do is label your picture. We know that TR is 4, PS is 10, and that we're looking for MN, so I'm just going to put an X there because that's what we're looking for. Then the next thing that I would do is make a note for myself that this is one of my bases, B1, and this is my other base, B2. It doesn't matter which one's B1 and which one's B2. This could be B2 and this could be B1, or this could be B1 and this could be B2. Doesn't matter. As long as we correctly label that those two are the bases. Okay, so then it's just adding those together and dividing by 2. So that would be 10 plus 4 divided by 2. Make sure you do the addition first. 10 plus 4 is 14. Divided by 2 gives us 7. So that would be the length of our mid segment, MN. Okay. Any questions on that one? Any numbers we're not sure where they came from? Any steps we're not quite sure how they work? Okay. So hopefully that one's fairly straightforward. Add the two together, cut it in half. Let's do another one. So this one steps it up a level just a little bit. This time we're told that PQ is 8, TU is 12, and we want to find SR. Okay, so for this one, same kind of idea. We want to go through and label the picture first. So PQ is 8, TU is 12, and we're looking for SR, so that's going to be X. And then I want to make sure I've got my bases correct, so this one's B1 and B2. And I know my mid segment is equal to B1 plus B2 divided by 2. So that's what I'm still going to do here, B1 plus B2 divided by 2. So that, in this case, would be X plus 8 divided by 2. And it's equal to my mid segment. So X plus 8 divided by 2 is going to be equal to 12. And then we got to solve that equation. So what I would do first in solving that equation is make sure on both sides I multiply by 2 first to get rid of the denominator. And so then we have x plus 8 equals 12 times 2 is 24. Then we can subtract 8 from both sides and get x equals 16. So that would be our answer. SR is going to be 16. Okay. So those are kind of the two main types that you'll see. We'll go over one more though, because the last one that we have is going to involve a little bit of algebra. So this time, we're going to be told that LM is x plus 3. PQ is 15. And ON is 4x plus 7. And we want to solve for x. So again, first thing I would do is label my picture. LM is x plus 3, so here's x plus 3. PQ is 15. ON is 4x plus 7. Okay, so here's my two bases, the top and the bottom. Keep in mind your trapezoid could look like this, where it's kind of on its side. This would be the base still though, B1, B2. So we're still starting off the same way, adding the two bases, x plus 3 plus 4x plus 7 divided by 2. And that's going to be equal to 15, since that's our mid segment here. So then we want to combine our like terms and get 5x plus 10 divided by 2 equals 15. Then we can multiply by 2 on both sides to get rid of the denominator. So we get 5x plus 10 equals 30. I'm going to move it up here so we have a little more room. Minus 10 on both sides. We get 5x equals 20. Divide by 5 on both sides, we get x equals 4. Okay. So those are kind of 3 different levels of problems that you'll see with trapezoids and mid segments. Any questions on either of those 3? Any numbers we're not sure where they came from? Equations we're not sure how we got them? Anything we want to go back to? Okay, then the last thing we've got to talk about for today is kites, and kites is a lot shorter and sweeter. So yeah, it's not going to take 2 pages worth of notes like the trapezoids did. It'll be a lot shorter. There's a lot less stuff you can do with kites. But anyway, moving along, the last thing of the day, kites. Okay, so just like trapezoids, kites have their own special set of properties. They're not the same as, they're not a parallelogram. They're not like trapezoids. They are different. Um, but they are drawn kind of like, the kites you thought of as a kid with the little tail and the. You don't have to draw the tail on your kites in geometry, but anyway, it's that same generic shape though. So, properties of kites. First one, two pairs of adjacent congruent sides. Or I guess they're more like they're connect. I guess it's not adjacent like angles adjacent, but they're consecutive sides that are congruent. It's not the opposite sides. And then one diagonal bisects the other. And we'll see which one bisects the other one when we start drawing pictures. The diagonals are perpendicular. So they meet at 90. And then we have one pair of congruent opposite angles, but not both pairs. Also, kind of a side note to that, one diagonal bisects the pair of angles that are not congruent. Okay, but to see how all of these work together, we're going to need a picture. So I'm going to draw us a kite, make it nice and big so we can see what's going on. Okay, so first we're going to deal with the two congruent sides. We've got these two sides are congruent, and then the two longer sides are congruent. So they're ones that are touching one another. The rest of this involves the diagonals. So I'm going to draw the diagonals corner to corner here. Okay, first off, the diagonals are perpendicular. They meet up at 90. Secondly, this diagonal, the one that goes from the corners that connect the two congruent sides, this is called the main diagonal. And the main diagonal cuts the other diagonal in half. So these two little pieces are equal, but these two are clearly not equal. Then we have to deal with the angles. We have one pair of congruent opposite angles. It's the angles that are connecting the sides that don't match. So these two sides don't match. This angle is the same as the other angle that connects the sides that don't match. These two angles, though, are not the same, but they are bisected. Okay, so that was a lot of stuff, a lot of properties, but most of our problems are going to be fairly basic, straightforward problems, which is good. So we're going to do a couple of examples with kites, and then we will get to the homework. And today's homework will be in IXL, not big ideas. So for those of you that are kind of tired of the big ideas this week, we get an opportunity to shift gears a little bit. Change it up. But I will wait a moment and let people finish writing before we move on. Okay. So here we go. One of the most common problems that you'll see when we talk about kites. You'll be told that this angle is 95 degrees and this one is 70 degrees. And we want to know, let's see, we'll call this thing PQRS. We want to know what is the measure of angle S. Okay. So if this is a quadrilateral, what do all four angles together add up to? $360. Thanks, Adon. Yes, all four angles together add to 360. And since this is a kite, we know that these two angles will be the same. So I can call them both x. So the equation I'm going to set up, x plus 95 plus 70 equals 360. Then, combining our like terms, we get 2x and then 165. Subtracting 165 from both sides, we get 2x equals 195. Dividing by 2, we get 97.5. That's going to be by far one of the most common problems that you'll see. Okay. Another kind of problem that you'll see has to do with more of the sides. So we'll see something like A, B, C, D is a kite. Find the perimeter. All right. So remembering that perimeter is the distance around the outside. And since AB is 15, this one will also be 15 since it's a kite. Since DC is 25, BC will also be 25 since it's a kite. Usually you would also want to be told a little bit more information like which two sides are supposed to be the same, like it could be AB and BC. A lot of times you can do it by looks, but if we're just finding the perimeter and we know the two different side lengths, we can just add additional side lengths So 15, 15, 25, and 25 without really knowing which side they belong to. But anyway, that gives us a total of, let's see, 15 and 15 is 30, plus 25 and 25 gives us a total of 80 for the whole distance around the outside. Okay, so those are kind of the two main types of kite problems that we're going to see so far. I might show us another type tomorrow, depending on what I see on the big ideas side of things. But I think this is most of what they deal with as well. Anyway, any questions about either of these problems? Okay, so on a scale of 1 to 5, 1 being like I'm completely lost and don't know how to do any of these, 5 being like this is super duper easy, I could teach this to everybody, what are we feeling? Everybody awake out there? Thank you, those of you who've responded. Okay, so I'm going to post the homework and we're going to take a look at it together, judging by responses so far, and then we'll kind of go from there. Okay, so let's go ahead and take a look at Google Classroom. Might have to refresh the page. Okay, so we have IXL, N11 and N12 to a smart score of 80. One's about trapezoids and one's about kites. Oops, sorry, it's N10 and N11 then. I must have read the numbers wrong. Yep. Okay, anyway. It'll say something like DE is not parallel to BC. What is BC? So in this case, what sort of trapezoid are we dealing with? A regular one or an isosceles one? How might we be able to tell? When we know we've got these congruent base angles, right? So that tells me it's an isosceles triangle. So if this is 96, then that opposite side is also going to be 96. That's one kind of question we'll see. Another kind we'll see is something like this, where we're just dealing with another isosceles trapezoid, and we want to know if this angle is 143 degrees, what's this angle going to be? Well, I know these two angles are the same, Q and T, because it's isosceles. So then these two are going to add to 180. So I can just go 180 minus 143, which gives me 37. Then we start getting into mid segments. So this would be the mid segment here. And it tells me that UX, the mid segment, is 69. ST, one of the bases, is 85. So this is where we have to go 85 plus X, the other base, is equal to 69. So that's going to be just like that second example that we did under the trapezoid mid segment problems. Okay, so that's going to be mostly the kinds of problems that you see on your properties of trapezoids 1. Properties of kites, on the other hand, is going to look a lot like the first kite example we did, where you've got, oh, this is almost exactly the first kite example that we did. Yeah, instead of 95 and 70, though, it's 95 and 75. So you take 360, you subtract away these two, and then you cut it in half. So in this case, we're going 360 minus 95 minus 75, which is 190, and then dividing it by 2, we get 95. And then you get another one that's pretty much the same process. You'll find that this section in particular goes really quick because most of the problems are the same kind of problem. So hopefully we get really good at those kind of problems. Okay, so like I said, this is the last day of new information that we need to know. Tomorrow we're just going to be practicing all we've done this week so far. Any questions before we get out of here? Okay. Then, unless you have any questions or want to go over any problems with me from anything, you are free to go and have a good rest of your day. See you guys later.